And everybody got your emission system test 13 in front of you. This is a scan tool diagnosis overview, or whatever you want to call it. Technician A says the first step. Don't you love Technician A and B questions? What you're going to like about the automotive electronics final exam is I have eliminated just about every one of the Technician A and B questions. There's 39 questions on the test, but all the Technician A and B questions except I think one are gone. I went to a lot of trouble to try to make that a little easier for you guys over there. Well, it's 2 questions. It's 2 in 1. It's a double. It's like having twice as many questions, isn't it? Now, I will tell you this. The other side of that deal is you will see a lot of those on the ASE test because they like those. So when you take an ASE test, you're going to see them. Okay, so you guys are all going to be ASE certified. You're going to register for the test and go take a test and get ASE certified in these categories that we've studied this semester, right? That's going to help you if you do that. Okay, I see a bunch of nodding going on in here. So, okay, Technician A says the first step in the diagnostic process is verify the concern. Okay, how many of you guys have drawn an invoice or a ticket or a work order or whatever? Do you start working on something and before you even do anything, you just fly out there and start taking stuff apart? You ever do that? Yes. Without even verifying that you know the problem is there? You see? Now, what have we been doing on the Dodge van that we got out here? He says sometimes it cuts up and acts up and don't hardly run. We've been driving it, haven't we? Trying to get it act up. There ain't no codes that are coming out of it. All right. Technician B says the second step is to perform a thorough physical inspection. Who's right about that? Okay, here's the caveat. Both of those guys are right because you're going to verify the concern in as much as you can. You're also going to perform a visual inspection. But here's the other thing. If it is an intermittent problem, if it's only there sometimes, don't go pulling on wire harnesses and hoses and all that kind of stuff. Don't move around and let your fingers do the walking and all that, because what may happen is you may temporarily move something so that it moves away from whatever it's scratching against, or it may wind up temporarily fixing it. And you think, yeah, I fixed it, but I don't know what I did. And then it leaves for about a day or two, and then it comes back just like it was, and now you're back where you started. Now the customer's ticked off because they've had to bring it back. So the smartest thing you can do is get you a really bright flashlight and look everywhere where you can look without touching anything. If possible, you need to have some kind of an indicator. You know how when we're looking for the fuel trim problem, like if we've got a fuel trim that's been adding some fuel and we're wanting to maybe shoot a little carburetor spray or use a little propane or whatever, you know, to try to get it to determine if we got a vacuum leak before we hook up our smoke machine. You're going to be watching your short fuel trims real close while you do this in very targeted areas. And if you see that fuel trim start to move in the other direction really fast, a short fuel trim, you know. So you need an indicator. If I'm pulling on something, if it's an electrical problem, I'm going to be taking over here. I'm going to have some kind of, I'll have a meter. I'm going to have some kind of an indicator light. I'm going to have something over there at the business end of this in the relay socket or whatever. And as I pull on this, I'm going to see if that light comes and goes. You got me? Here's another thing. Let me tell you this story. This is really important. We get a mass airflow sensor code on a 96 Chevrolet pickup truck, right? And just throw in a mass airflow sensor code. Just nothing coming out of the mass airflow sensor. Hoses are hooked up, air's flowing through it, nothing coming out of it. So happen to have another mass airflow sensor on hand. So we plug the mass airflow sensor in, nothing changes. And we know the other mass airflow sensor we plugged in is good, but nothing changes. So what do you think we're going to do next? Talk me through this, folks. What about it? We're going to look at the schematic. We're going to see what's necessary for the mass airflow to work in the way of electrical. We're also noticing there is a hot wire going to the mass airflow sensor on that particular one. If I'm not mistaken, it's a pink wire with a black stripe. Pink wire with a black stripe is dark. We check it with a test light. There's nothing at the mass airflow sensor. Could this be the reason the mass airflow sensor isn't reading anything? There's no power going to it, right? So we look over there and doggone, there's a fuse feeding that. And we look at the fuse, and the fuse is actually blown. And say, well, that's no problem. We'll just put a fuse in there. So we take a fuse, and we stick it in there, and it goes pow. As soon as we stick that fuse in there, poof, we can see a little welding arc. And the fuse is gone. All right, so now then, well, that's really a sweet thing. We got 7 more of those $12 a piece 3-valve forged spark plugs. I heard somebody's buzz. Bzz, bzz. It sounded like a cell phone on a movie, didn't it?
Mm-hmm.
All right, you know what to do with these. Put these out there where that expedition is, that navigator is on the other side of the All right, so anyway, here's the thing. I'm telling you this story for a reason, because stories are good. They're our friends. It's a true story. I'm not making this up. All right, now then, we blow in a fuse when we put a fuse in there. What's our next step? How are we going to find out where that problem is? This is not an intermittent problem. It's a hard fault.
Look at the schematics for the fuse.
Well, we already found that. We know where the fuse is. We're going to look at the schematic for everything that fuse feeds, right?
That's what I just said.
Well, you said look at the schematic for the fuse?
Yeah.
Okay.
Look at fuse powers.
Okay. Well, I'll let you get by with that this time. But what we do is we find out that it's kind of going a bunch of places. It's feeding a whole lot of stuff, among which are the heaters and every oxygen sensor. There's 4 oxygen sensors on that darn thing, and that same wire's feeding those 4 oxygen sensors. Now, there's one thing we can do. We can actually go and do something, like disconnect other components it's feeding, and we can put a fuse in there and see if it pops a fuse. How many fuses do you want to burn before you find it?
5.
All right. Okay, watch this. This is how we're going to do. We get a circuit breaker, the 2 little bolts on it. If you look at it from the side, it looks like this. And it's got a short bolt and it's got a long bolt. And you want one that's pulling about 8 amps, right? For this purpose. All right. Now, looking at it from the top, y'all watch, because this is important. Because I got some of these built up anyway. That's what the circuit breaker looks like from the top. Now, right here, I'm hooking up a light bulb. Little light bulb. Don't have to be very much of a light bulb. It's going to be a light bulb, like one of the little bullet bulbs that you put in a park. You can get a little socket bulbs like we got. Coming off the other side, I'm going to hook to a fuse adapter so that I can put it where the fuse went. All right. Now, as long as that short's there, this circuit breaker is going to be kicking off and on. It's going to be going ding, 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 ding. As long as that short's there. And every time that circuit breaker opens the circuit, this light's going to come on. And then when the circuit breaker closes it up, the light's going to go back off. It's going to go back and forth. Now then, we've got a fuse that's replacing itself about every 5 seconds. Got me? Now it's important to put a circuit breaker that doesn't doesn't take very many amps to trip. Whatever your circuit is ordinarily pulling, you want it to be about that. If it's a 10 amp circuit, it won't be 8 or 10 amp. So then we go and we start unplugging stuff that's also fed by that pink wire with a black stripe. And the whole time we're doing it, we're watching this. This is our indicator. And it's going ding, 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 ding. So, lo and behold, when we unplugged the oxygen sensor that was behind the catalyst on the passenger side, this went away. The circuit closed, the light bulb went off, everything normalized, the mass airflow started talking. What do we know now? What we got deer in the headlight looks for. What have we learned from this exercise that we did that's going to help us to determine what we need to do to fix this truck? I disconnected the oxygen sensor that's behind the catalyst on the right side. What do we need to do now to complete this repair?
No sensor.
Put a sensor on it. Yeah, was the question too simple? Just put a sensor on it, plug it back in, and we're good to go. Do you guys get what I'm trying to teach you here? This is how you find a problem. Got it?
How did the oxygen sensor make the mass airflow sensor not work though?
Because they were both fed by the same power source. The mass airflow had no power going to it. It was asleep because it has to have that power going to it so it can warm up those hot wires in the sensor. Okay, the oxygen sensor is fed, all right, you see right here, you got MAF, and it's fed by the same wire that happens to be feeding this oxygen sensor, and then there's a fuse, right here. All right, when you blow this fuse, because this sensor is shorted to ground internally, not only did you know, the sensor blew the fuse, but you lost your mass airflow because the mass airflow is dependent on the same power. That's what happened there. Got it? Now, understanding that is going to make you a better troubleshooter. It's more important. You remember the little mantra on the wall I got out here? Not knowing how to change parts is not as important as knowing which parts to change. Right? That's part of it, but anyway. I sort of went off. I spent 10 minutes on that, but we're okay. Which item is not important to know before starting a diagnosis of an engine performance problem? A, type of gasoline. B, list of previous repairs. C, brand of engine oil used. Or D, the temperature of the engine when the problem occurs.
C.
That's going to be C. You don't need to know what kind of engine oil you're using unless it's directly related. Now, here's another thing. That's not totally true because some engines that have funky things they do with the valves with the engine oil, if you put an engine oil in there, like in that 3-valve Ford out there, one of them, that's using the variable cam timing, if you dump oil in there that's the wrong, like if you put 2050 Castrol in it when you should have put, 530 or whatever, you may have engine performance issues because of that. So be aware of that. That's not really a good question. Number 3, a paper test can be used to check for a possible problem with what?
C.
D.
That's actually ignition system, faulty port, burn valve. That's something you can find any of those on. You remember how I tell you to put your hand at the exhaust pipe whenever you got the engine running? Remember that, Quincy? And it goes pop, 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 pop. When Quincy and them got through with that Oldsmobile yesterday, it ran like a sewing machine. That's what you're supposed to feel at the pipe, right? Which steps should be performed last when diagnosing an engine performance problem?
Verify the repair.
There you go. Verify the repair. It's a good thing. Technician A says if the opposite diagnostic trouble code can be set, the problem is the component itself. Technician B says if the opposite diagnostic trouble code cannot be set, the problem with it with the wiring or the grounds. Well, what are they talking about there? Did I talk about this one time before? Did I or did not? Did I
I
not?
don't think you did.
I did. Three wire sensor, right? Okay, signal. This is your signal return. That's your 5 volts. This is your zero, which is going to be going. And this is a signal that varies. Okay, let's say this signal right here is non-existent. This has got a 0-volt signal on it, and your PCM is throwing you a code, whatever, for not having for having no TP signal. If I disconnect this, right, and I jump this to here, and this goes to 5 volts, you're going to set the opposite code. I had no voltage, now I got too much, right? Well, let's say that you had 5 volts here, and we jumped it here, and it pulls to no volts. See what I'm saying? Basically what you're doing is, if you can set the opposite code, you've checked your wires and you know they're good, your sensor's got to be what the problem is. That's what they're talking about. That's an old thing there that's been around for a long time. All right, let's see. The preferred method to clear diagnostic trouble codes is to do what? Cycle the ignition key off and on 40 times, remove the computer, power feed fuse, disconnect the negative battery cable for 10 seconds, or use the scan tool. Preferred method, you all. Hello?
Scandal.
Scan tool makes more sense. Which is the factory scan tool for Chrysler brand vehicles equipped with, huh? No, I just went through number 5 up here on the board.
Well, what was the answer?
No. Did you couldn't figure it out from what I said?
No. Oh, I go in and ask.
Can you set the opposite DTC? If you can, the problem's with the component. That guy's right. Technician B says if the opposite DTC cannot be set, the problem's with wiring or grounds. All right. And when you're taking your final, I'm not going to be here to spoon feed this to you. You better be able to think and figure things out. Hey, Tim.
Hey, I hate to bug you in, but I was going to tell you something. On my truck, I left out here for inspection.
Sure.
The thing's just bogging down to nothing. I don't know.
You mean when you're taking off? Or?
Yeah.
Okay.
And like I turn off an intersection and start climbing, second gear, it just bogs down.
Okay. Yeah, we'll have to look at
Acts
that.
like
Did it start doing it all at once, or?
Well, it's just gradually got worse.
Yeah.
The last. It acts like the dang catalytic converter stopped up.
Yeah. Yeah, we'll troubleshoot that.
Just smothering out to nothing. It don't,
Okay.
don't have any power. Then when you press it on down and it jumps back down into passing gear, it seems to go.
Okay.
Alright.
That's interesting. All right, we'll have a look at that.
All right, appreciate it.
Let's see there. We got a customer. You guys can use what we're getting out of this test to figure out what's wrong with that truck.
Oxygen
06?
sensor.
Huh?
Oxygen sensor.
We'll see about that.
I'm
You're
right.
kind of thinking in the right direction. I was thinking if you kick it down and you force it into open loop,
Sound like a fuel pump, same thing doing them.
Similar, yeah, that's a possibility. Fuel pump, but you guys think catalytic converter is what he was thinking. Fuel pump possibly. Of course, if you get on down, it probably wouldn't do it if it was a fuel pump. Fuel filter would be a good thing to check. I mean, that's a good deal there. All right, it's interesting we're doing this and he comes in here with that problem. All right, let me see here. Let's see, which is the factory scan tool for Chrysler brand vehicles equipped with controller area network? I'm sure you guys all know that one. StarScan or YTEC? Technician A says programming a PCM using the J2534 system requires a factory scan tool. What do you think about that? That's not true. I got one of these J2534s out here. Technician B says reprogramming a PCM using the 2534 just requires internet access. That is true. You have to have internet access because you get to download your calibration information. Technician A says that knowing if there are any stored diagnostic trouble codes may be helpful when checking for related technical service bulletins. Technician B says that only a factory scan tool should be used to retrieve diagnostic trouble codes. That's A only. Smart thing to do now. Remember this, and some of you guys don't remember this. You pull a bunch of codes, you got a big laundry list of codes comes out. What do? You dump the codes, record them first, dump the codes, and then drive it again and see which ones come back. Smart way to do it. Which method can be used to reprogram a powertrain control module, direct, off-board, remote, or any of these?
Any of these?
Any of these. How many steps does the book outline for a simple diagnostic procedure?
4.
8. Second-rate amateur, didn't know how many steps. What is the first step of the diagnosis process? We already covered this. What is it?
A.
Verify the problem. Good answer, Curtis. All these actions involve verifying the problem except what? Verifying the problem, you're looking for technical service bulletins is not verifying the problem. It's a good thing to do, but that's not part of the verifying the problem process. Technician A says it's a good idea to perform a test drive before attempting repairs. Technician B says it's a good idea to let the customer accompany the technician on the test drive. Who's right about that? Now, I will tell you this, for some strange reason, some shops don't like the customer talking to the technician, but that's bad policy because sometimes the technician will pick up on stuff when he's talking to the customer that the service writer will not. On the flip side of that, sometimes you'll have tricky customers. I had a customer one time that says, what would you do to this truck if it was your truck? And it had about 150,000 miles on it. I said, I don't know if it's my truck, I'd probably put a timing belt on it, timing chain on it. And so he went straight to the service manager, and his truck was under some sort of extended service plan. He goes, that man told me my truck needs a timing chain. Well, you can't just put a timing chain on there because you want to put one on there. There's got to be a problem with it, Anyway, he's trying to get somebody in trouble, trying to get a freebie. So you kind of got to be wise whenever you're talking to customers and recognize what, be able to see through that kind of thing. Let's see. Technician A assumes the replacement part is good just because it's new. Technician B says sometimes recent repair work will be the cause of a complaint.
Let's get 14.
14 is good.
Oh,
Well,
never mind, I read that wrong, sorry.
a second-rate amateur told me I skipped one I didn't skip. Okay, technician A says assuming a replacement part is good just because it's new. What does the letter NEW stand for? What does NEW stand for? Hey guys, what does the NEW stand for?
What?
NEW, the word new. What's that stand for? Never ever worked. New means it's never worked. So you don't know if it's good or not. You just know it's new, right?
NEW.
Yeah, this is in context of the question. Technician A assumes replacement part good just because it's new. Technician B says sometimes recent repair work will be the cause of a complaint. That's B. I've actually seen them where I had to go back and undo what the last 4 or 5 guys did and put it all back like it's supposed to be before I could find the actual source of the problem, Which diagnostic step is the most important aspect of diagnosis? What do you think? That's sort of a dicey question, isn't it?
Visual inspection.
Good answer, Curtis. Curtis is a thinker. You been reading the chapter, Curtis? Technician A says when checking engine oil, it's normal for the oil to catch fire if lit by a match. Should engine oil catch fire if you light it by a match?
I don't think so.
Technician B says oil on the dipstick that catches fire is a sign of fuel in the oil.
I'd say B then.
That's 17. That's B, yep. Technician A says to check coolant level in the radiator when it's hot. Technician B says check coolant level in the radiator when it's cool. Who's right about that? If you check it when it's hot, you may get burned. Don't be a dummy, okay?
Had no idea that was
Yeah, did you do that? Did you have a good time? Did you get burned?
No, I mean, it wasn't too hot, but
You were quick. When I was about 18, my 69 LTD was always overheating. When I'd be driving it, I know heat. I knew, oh, I'm low on coolant again. And so I'd get out there and this thing, pretty warm. I had my nice school clothes on and everything, and pop the hood on that thing out in front of Jeff Davis's store by his water hose. And I pushed down that radiator cap, and I was like, all right, poof, jump out of the way. And I get the water hose and fill it up. But if you knew what you were doing, if you knew it was gonna come out there, you could just dive out of the way and it just make a geyser, That girl that rode to school with me would be traumatized by that. Okay, let me see, which one are we on? I forgot. Technician A says water floats to the top of the fuel in the tank. Technician B says water is more likely to be drawn into the system when the fuel level is low. Who's right about that? That's B. Water's not gonna float on the top. Water's heavy. A gallon of gasoline weighs about 6 pounds. A gallon of water weighs 8 pounds. The water is heavier than gas. It's going to be on the bottom. You're more likely to get it when you're low fuel level. Technician A says low battery voltage can cause drivability problems. Technician B says the charging voltage should be over 15 volts when the engine is idling. Who's correct about that? Battery voltage can cause drivability problems. And the charging voltage, should it be over 15 volts when the engine's idling? No, it shouldn't. You know better than that, so that's A only. Let's move on. Technician A says a standard spark plug can be used to check proper ignition system voltage. No, you can't use a standard spark plug for a spark tester. Technician B says energy required to jump the gap for spark tester is around 3,000 volts. Oh, goodness gracious, neither one of those people are right. Technician A says a vehicle may have stored diagnostic trouble codes even if the malfunction indicator light is not illuminated. Technician B says all diagnostic trouble codes will illuminate the mill. You guys know any better than that? Have you ever gone in there when there was no diagnostic, there was no mill on, but you still got a diagnostic trouble code? You also have pending codes that haven't turned on the light yet, but they're coming, right? If we keep seeing this wrong, we're going to turn the light on. Okay, let's see. Technician A says most technical service bulletins involve a specific stored diagnostic trouble code. Technician B says the engine coolant temperature and intake air temperature sensor reading should be close to the same temperature after the vehicle sits for several hours. What about it? Both those guys are right. Usually on a technical service bulletin, they're saying if you see this diagnostic trouble code and you check this, this is going to be your problem. Technician A says a power balance test is the best way to isolate a problem cylinder. Who has done a power balance test lately? Hello? Power balance test, you did. What'd you do it on? The Oldsmobile yesterday. Remember? We were killing the cylinders one at a time, see which one didn't make any difference. Yeah, we can't believe you didn't remember that. Yeah, he was just letting the answers be spoon fed without thinking. Is that what you do? All right, let me see here. When should diagnostic trouble codes be cleared? After pinpointing a problem cylinder, after the repair has been verified, after the problem has been verified, after consulting technical service bulletins.
You skipped 25.
Well, let's go ahead and talk about 26 and we'll go back to 25, okay?
After the repair has been verified?
Yeah, after the repair has been verified. That's a good deal right there. I think I'll just keep on skipping 25. I'll let y'all answer that by yourself. How about that? Technician A says a symptom may be corrected without correcting the cause of the problem. Ooh! You can't figure that one out? What's the symptom? What are you talking about? I've got a foul spark plug. You put a spark plug in there, and now it's running good. But have you necessarily repaired what caused the spark plug to foul? If it fouls again, you'll know you didn't. Correct? Now put another spark plug in there. Well, here's another thing. I'm going to make, this is a guy that's got his air conditioner not working, and he keeps popping a fuse. And he goes, well, I get so tired of this fuse popping, I'm going to go ahead and just get me a piece of 2 Romex wire and bend it into a U and stick it where that fuse goes because it won't blow and my air conditioner will quit working or keep working. Well, the air conditioner worked for a little while and then it burnt the dadgum wire harness up. Why? Because the clutch on the air conditioner was shorted. Did he fix the symptom without fixing the problem? He caused bigger problems, right? So you can fix the symptom without doing that. Okay. Let's see. Technician B says verifying the repair will determine if the root cause of the problem has been repaired. Usually it will, but you're going to have to really do a lot to verify some repairs, you know. Like for instance, if you got evaporative leaks, you know, you got to drive the heck out of one to get that evaporative monitor to run. Which of the following should be checked before returning the vehicle to the customer? Radio's turned off, radio presets and clock have been restored, vehicle's clean. All of these are correct.
All.
That's right. Let me tell you, when I'm working on one, if I can do it without moving the seat, I do it without moving the seat. If I can drive it safely without moving the steering wheel, the seat, or the mirrors, I don't bother that. I turn the radio off. Unless I'm working on the radio, I turn the dadgum radio off. Don't change the radio station and want to listen to your music. If they're listening to orchestra music and you want to listen to head banging, boop, 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 and you forget to change that thing back, you head that thing back, and they get that car back, they're going to be ticked off because who in the world has been playing this boop, boop, boop music on my radio, you know? People don't like that. I knew one guy that got fired because he had the radio and some guy's vehicle turned up really loud. He's out there changing the oil in it. And the guy happened to hear that and went out there and looked, saw it was his car and threw a screaming fit, and the service manager fired the guy that was doing the work. It is not your right to tinker with a person's radio or rifle around in their glove box or their console and see what they've got in there. Leave the heck alone, man. If you've got to work in the console and you got to get the stuff out of the console, try to put it back just like you found it, you know. All right. But don't go anywhere in there that you're not supposed to. Don't change nothing you don't have to. Clean the steering wheel. Wipe things off really good. If that steering wheel is cleaner when it leaves than when it came in, that's a good thing. You can do every job right. Have half of a dirty fingerprint on somebody's fender and they'll never bring your car back to you again. You know, make sure you wipe it off. I knew one customer looked under there after the guy worked on the transmission and said there's too many greasy handprints on the frame. Underneath the car. Some people pay attention to stuff a lot more than you think they ought to, right? But they're the customer and they paid them a bill, so all right. Here we go. Where are we at?
28.
Which technician A uses a scan tool to clear the DTCs. Technician B says clearing the DTCs will also clear all of the non-continuous OBD2 monitors. Now that's typically, yeah, both technicians are typically right about that, but I've seen OBD2 monitors that weren't cleared when you cleared the enhanced. Which pins of the DLC should be connected to in order to receive flash codes on a GM OBD1 PCM? Now you're not going to know that, but that's A and B. A and B, pins A and B. Which tool should be used on Ford OBD1 system to receive DTC if the star tester is not available?
See.
Analog voltmeter, or you can look at the check engine light if it's got a check engine light, right? How many times must the ignition switch be cycled to put a Chrysler computer in self-test mode?
5,
No?
1,
What you got?
2,
8 again.
2. It says 2 here. In order to make the, from my personal perspective, I like to switch it on 3 times whenever they used to have a power loss light. I'm not sure what they're talking about here. I could be a dummy. Technician A says generic scan tools must be able to read all generic. I think that's going self-test mode must be when it's energized and stuff. Technician A says generic scan tools must be able to read all generic OBD2 codes. Technician B says all generic scan tools must be able to read the manufacturer OBD2 codes. That's A only. And we're almost done here. Technician A says non-emission related codes that make the mill illuminate are called type A codes. Technician B says emission related codes that that illuminate the mill after the first fault are called type A codes, and that's B. If it illuminates it right away, it's a type A code, it's a priority thing. A type blank DTC is set if an emission problem may cause damage to the catalytic converter. What do you think? What did I just say? Based on what I just said, what is the answer to this one?
B.
That's going to be A, type A code. 35, you should have known better than that. He was just talking out of his hat. Type blank DTCs are set by non-emission related diagnostic tests.
A or B?
That's the old C and D, you know. A freeze frame is stored when what kind of DTC is set? A or B. Yeah, all right. Everybody happy?